Yeah, good evening all. Am I audible? Am I audible? Yeah, Bhavani, good evening. Banso, good evening. Sri Krishna, good evening. Mamata, good evening. Dharani Reddy, good evening. Banu, good evening. Yeah, Durga Bhavani, good evening. Thank you for your response, Mamata. Yeah, good evening all. Okay, so this is Indra from Pantech E Learning. So today we are in our 17th day of this 21 days masterclass, right? So today we are going to talk about the topic which is phase and eye detection with OpenCV. Okay, so I hope you are all are ready. So let me start. Okay. So in previous session we have learned that we could track on something like a pen or some object that has a distinct color, like we could find it, we could identify it. So today we are going to learn something really cool. We are going to learn how to do face detection. Okay, so this is kind of like our big next big step into the field of AI, which is artificial intelligence. So what we have been tracking on so far is something simple like color only, right? So here we are going to talk all the things that we have learned for past few days, almost 16 days we have came across, right? And we are going to apply them and start doing more artificial intelligence. So here one thing you need to understand is that the difference between face detection and facial recognition. Face detection is different, facial recognition is different. So what face detection does is it recognizes any face in a picture, okay, and says yeah, here is a face. It will draw a box around it, or the face, draw the box around the face or something else. So face recognition is if you have like 10 people, 10 different people, and it recognizes who is who. So that's a lot harder, right? So let's start with face detection first. Here it is going to look at the image and it is going to find and box the faces. Okay? You didn't even get today's attendance link, but you directly go for tomorrow's attendance link, right? Okay. Fine. You won't get any attendance link, not today's, not tomorrow's, not yesterday's. You have to wait until the end of the session, then only you will get. Okay. So in order to do this, you have to have like training sets, and these are called like Haar Cascades. Okay. The data sets are actually called Haar Cascades. HAAR Cascades. And the goodness is that a lot of training data sets out there. You don't have to create your own database because already someone have done that. So you can just go and grab that data set and you can use it in your program. It's quite easy, isn't it? You don't have to ready all those steps from the scratch. You just go to that particular site and you can get all those training data set and you can work out in your own program. Okay, so we are going to using those pre-trained model to do things like recognize faces and recognize eyes. So later on we could go and start working on things like facial recognition where we can recognize people. So today we are just going to detect the face and eyes of the particular picture or people, and in the upcoming session we can go for recognition. Okay, so for that, okay, so first let us try with the code that we have already used it in the previous session, but we need to check whether our camera and everything is working properly or not. Okay, so first let me check with that particular program and then we can start with it. Okay, so for that let me go to my here, let me cancel it. Okay, let us go to our Visual Studio Code first. So it will take few seconds because it's lagging. Okay. Okay, now so let me go and open one new file. Let it be demo.py. Okay. So here, as usual, the basic program, we need to test whether our camera is working properly or not. Then only we can go for all these steps. So you already know all these steps. Import CV2 and then, sorry, not import. We don't need numpy anything over here. So print CV2 dot underscore the version of CV. Now let's initialize the video capture object. So cam, which is equal to CV2 dot video capture, and instead I'm going to pass 0 because I'm using USB camera over here, right? And then let's get into the while loop. T should be in uppercase, that is the main thing. And okay, so now inside ret comma frame, which is equal to cam dot read. Okay, so ret, this is a boolean indicating if the frame was successfully captured or not, and then frame, the actual frame captured. And now let's display. Okay, so now let's display the frame. Okay, okay, fine. So for that, CV2 dot IM show, inside let me provide the window name that I want to display, which is, let it be video, and then I'm going to pass the frame. Okay, so this particular line will display the frame in the window titled video, and then CV2 dot move window. Okay, so inside also, sorry, we need to pass the steps called thing, and then x-axis and y-axis where I want to place that video. So it moves the video window to the top left corner of the screen. Okay, so now let's write break condition. So for that, if CV2 dot wait key, instead I'm going to just pass 1 over here, and then odd of q. It will, if you press this, it will shut down your, sorry, I forgot to add the colon over here, that's the important thing, otherwise you will get error. So it will wait 1 millisecond for a key press. So the odd of q, that will check if the key pressed is q or not. So if true, the loop breaks, ending the program. Okay, and then let me come out of this and cam dot release, and then CV2 dot destroy all windows. Okay, so windows I should be small. That is the program. Let me save it and check it once. Yeah, okay, it's working properly. So now let's go and do our today's thing. Okay, so now what we need to do is that we need to think about how to detect faces. For that, we need to get one of these pre-trained model that will allow us to detect the faces. Okay, so before getting into the data set, we need to create a folder to download that data sheet. Okay, data set. So for that, I have already done this part. Just go to your file manager. So here I am having one folder called like Masterclass. Okay, here I am having one folder called Masterclass. So you can create your own directory. And here I have already opened one folder called Cascade. Okay, the name is Cascade. You can provide whatever the name that you want. So here we need to download that XML files and we have to save it over here. So here you can be able to see that I am having two things. One is face.xml. Okay, and then another one is I.xml. Okay, so this is the two things that I have over here. So those who want attendance link, you can just join the end of the session. You can just leave the session and just come to the class at the end of the session. Okay, and don't complain that I didn't get the attendance link. We can't able to tell the accurate time when we post it. If you want it, you have to wait until the class. Otherwise, you can just leave the session. Don't disturb the remaining members. No, I think my screen is properly able to see. I don't think like that. Okay. Okay. So let it be. And how to download these files? So how to get these files? Right. So we can go for like Chromium web browser over here, right? So just a minute. I don't know why it's showing black to you guys, but I think this is perfect for me. Okay, so now you can just go to Chromium web browser. So just click on it. It will open. Jia Kumari, I am telling you this again and again. You won't get yesterday's attendance link. This is your mistake if you miss the attendance link. In the sense, you have to be active in the class until the class end. If you miss yesterday's attendance link, in the sense, we can't able to provide it here. If you missed, it will be missed. We can't able to provide it, so please don't repeat the same thing again and again. Okay, so here you have to search for like Haar Cascades for Open CV. Okay, so Haar Cascades for Open CV. Search something like this. So the first link you can able to something here like, let me make it big. You can able to see it properly, I think. Okay, over here you can able to see something like GitHub link, which is OpenCV tree master data, something like that. So OpenCV Haar Cascades. Just click on it. It will throw you some files over here. You may have a lot of files over here, but you have to choose accordingly that what you need. Here you can able to see some files like Haar Cascade i.xml file. So this is the one thing we need it, but we need it later. Now I don't need it anymore. This is called like Haar Cascade front cat face. So if you go for this, it will only able to help you to detect the cat face. If you downloaded this file, if you go with a person's image, in the sense, it will not detect, because you can able to see this is a frontal cat face, not for human. So just go for it. Haar Cascade front. So you can download it and just save it wherever you want. I have saved it already in my folder, and this is also you will need in the upcoming topic, which is Haar Cascade i.xml. Okay, so I have already downloaded it. Okay, so now what we are going to do is that here we need to load the cascade. We need to load that particular cascade in our program. Okay, so for that what we need to do, first we are going to detect the face. Okay, so first we are going to detect the face. So in the same program, we are going to add few more lines over here. Okay, so for that, let me just, before getting into that, let me just go for this particular stuff, which is you can convert this 21 days of masterclass into 1 month internship on Jetson AI. This is only for registered masterclass students. And in this 30 days internship, you will get 30 days of recording sessions, 30 days of presentations, 4 plus exclusive project codes, and you can join to the VIP community group, and you will get LMS access for 90 days. And after registration, you will get your internship confirmation letter, and there will be a hackathon session for every week, and you will get your mock test, assignments, and tasks as well. And at the end of the session, you will get your internship and participation certificate. I mean the 21 days. Today's attendance link have posted. So those who are asking for attendance link, just mark your attendance and leave the class. So the registration fees is only for 999 plus GST. So here is the registration link. If you want, you can register it. So this is the last batch. So this batch is gonna ends on coming Saturday. So because Saturday is our last day, right? So while making your payment, please don't forget to add all these details. And in this internship, you will be doing 4 plus projects with me. And this offer is going to end on coming Saturday. Okay, so now let's get back to our topic, right? Okay, so over here, so now we are going to load the Haar Cascade classifier, because for that we need to select the path and paste it over here. For that, I'm going to use something like face underscore cascade. Okay, so which is equal to cv2 dot cascade classifier. Okay, so inside here we need to share the path that I have downloaded. So for that, I can go to this. Here I need face.xml. Okay, so just right click on it. It will throw you properties. Go here. So just click on it, select all, and I'm going to select, I'm going to copy the path, and here I'm going to paste it. Okay, and the file name is what? face.xml file. Okay, so we need to provide that name also. So face.xml file. So after this, I can just go for the next line, which is, see, this particular line loads a pre-trained Haar Cascade classifier just for face detection from the specified XML file, face.xml file. Okay, so Haar Cascade is a machine learning based approach to detect objects in images. So ensure that the XML file path is correct and accessible. So if you give some mismatch path, in the sense you won't get the output properly. So you have to be careful with the path that you have provided, which is accessible or not. So please ensure that. Now let's get into the loop. For continuous frame capture, we have already created it, but we don't have to worry about that. And after this particular line, I'm going to convert the grayscale. Okay, so for that I'm going to use gray, which is equal to cv2 dot convert color. So instead I'm going to pass frame comma cv2 dot color underscore bgr to gray. Okay, so this particular line converts the captured frame from color to grayscale. So grayscale processing is faster and more efficient for face detection since color information is unnecessary. Okay, so now let's write lines for face detection. For that, I'm going to create one variable called faces. Inside face underscore cascade dot detect multi-scale. So inside I'm going to pass the gray stuff and then 1.3 comma 5. Okay, so this particular line detects the phases in the grayscale image. So 1.3, what it is? So this is a scale factor to compensate for different phase sizes. So decreasing makes detection slower but more accurate. Okay, and then comes 5. So this is the minimum number of neighbors. So increasing this makes detection stricter, reducing false positives. Okay, so this particular method returns a list of rectangles each representing a detected face with X, Y, W, and H. So XY means the top left corner of the rectangle, and WH means width and height of the rectangle. Okay. So now let's draw the rectangle around the detected faces. So for that I'm going to use a for loop. So instead I'm going to use that X, comma, Y, comma, W, comma, H. Okay. Width and height in phases. Okay, so inside this particular loop, so this particular loop iterates through all detected phases. Okay, so instead I'm going to add cv2 dot rectangle frame, comma, instead I'm going to pass X, comma, Y, and then here X plus W, comma, Y plus H, and then here 0 comma 0 comma 255, this is nothing but a color. Okay, and then 2, this is nothing but a thickness. Okay, so here CV2 dot rectangle, this draws a rectangle around each detected face on the original frame, and then X comma Y, this is like a top left corner of the rectangle, and then X plus W comma Y plus H, this is the bottom right corner, and then 0 comma 0 comma 255, which is nothing but a color of that particular rectangle, which is nothing but red in BGR. Okay, and then 2 is the thickness of the rectangle's border, and the remaining everything is same. You don't have to change anything over here. So now let's check and see. Okay, it should detect the face. Okay, I'm going to run this and let's see what will happen. Okay, I'm having one picture with me, actually supposed to detect the face over here. Let me, yeah, it's done. So I'm having one image with me. If I show, it's detected the face correctly, right? You can able to see it, right? Yeah, it's perfectly detect the face. You can also able to try with your face also, but I don't want to show my face. That's why I just go with the picture. Okay, I hope you like this. Okay, so now we are going to detect eyes also. We have just detected the face using the data set. We just need to pass all those steps in the program. So this particular program continuously captures video from the webcam and processes each frame to detect the faces using the Haar cascade classifier. So and highlights the detected face with the rectangle. So the program runs until the user presses Q, right? So this is how you can just detect your face. You're already having your data sets with you. You just need to pass few lines in your program, and you can try with your face or you can try with some pictures. Okay, so it's detected the face properly. This is how you can detect faces. Okay, so now let's move to the next thing, which is we are going to detect face and eyes as well. So we need to move to our next topic, which is face and eye detection. So here also we need to download another data set, which I have already told you that i.xml file, right? Okay, so I have already downloaded it. So what I'm going to do is that here I'm going to add few more lines for eye detection. Okay, so let us go and check. After this face line, here we can add something like eye cascade. Okay, this is for eye cascade, which is equal to cv2 dot cascade classifier. Okay, so inside we need to pass that particular file. So what is that file? Just go for file manager and let me close it, and here let me go for the properties over here, and let me select all, copy this. My file name is i.xml, let it be, and here I'm going to paste that path, and then i.xml. I think this is the correct name. Let me check once again. i.xml. Yeah. Okay, fine. Okay, now. Okay. So here cv2 dot cascade classifier and path. This particular line loads the pre-trained Haar cascade classifier for face and eye detection. So these XML files contain the models that needed to detect features like faces and eyes that we have already loaded it. Okay. So here face cascade, which is used for detecting faces only. Here eyes cascade, which is used for detect eyes only. Okay. Now let's get into here inside this while true. Here after this particular line cv2 dot rectangle, after creating all these line, here I'm going to add one more line over here. This is particularly for eyes. Okay, so here I'm going to take roi underscore gray, okay, which is equal to gray of, inside I'm going to pass something like y colon y plus h comma x colon x plus w is for width. Okay, sorry Radhika Kumar, we can't able to provide all those ppts. All those steps will be provided only for internship members, right? So I hope you understand this. We can't able to provide all those downloadables and materials. If you are internship member, in the sense you will get all those downloadable, otherwise we can't able to provide that. Yeah, if you want to get all those recording sessions, PPTs, what are the code that we have used in this entire masterclass and everything, in the sense, you need to be a internship member. You have to convert this masterclass into an internship member. Otherwise, we can't able to provide all the downloadables for free. So I hope you guys understand this, right? Okay. So here ROI underscore gray, which is equal to gray of something I have provided inside that particular thing. What is this? Here, actually we need to define the ROI. ROI is nothing but region of interest. So ROI underscore gray, that refers to the region within the grayscale frame that is corresponding to the detected phase actually, and then gray. So the grayscale image of the entire video frame. Okay, and then y colon y plus height comma x colon x plus width. What is it? This is actually extracts a rectangular subsection of the image where x and y, the top left corner of the detected phase rectangle, and then width and height of the detected phase rectangle. Okay, and after this again I'm going for like ROI underscore color, which is equal to frame of the same thing like y colon y plus height comma x colon x plus width. Okay, so now here this particular ROI color that refers to the same region within the color frame that is corresponds to the detected phase, and then frame the original color image which is in BGR format, and then here the same, it extracts the same phase rectangle as in ROI gray but from the color image. Okay, so now let's detect the eyes within the phase of ROI. So for that I'm going to take something called eyes. Inside I cascade dot detect multi scale. Okay, so inside I'm going to pass ROI underscore gray. Okay, so this particular line eyes, which is equal to I underscore cascade dot detect multi scale, inside I have just passed ROI underscore gray. So this detect the eyes in the ROI gray, I mean the face region. Okay, so it returns a list of rectangles, I mean the list of eyes that representing detected eyes with xi, yi, wi and hi coordinates. We are going to mention this in the upcoming line. So for that now let's draw the rectangle around the eyes. Okay, so for that I'm going to take something like for loop again. So here inside I'm going to pass something like xi comma yi comma wi comma hi, xi yi width I and height I in where eyes. Okay, so inside this particular loop, so this iterates through the detected eyes. I'm going to add one more line called cv2 dot rectangle. Inside I'm going to pass the steps like ROI underscore color, this is the first thing, and here I'm going to pass xi comma yi comma, and then here I'm going to pass xi plus wi, I mean the width I, comma, yi plus height I, okay, and then comma, inside I'm going to pass something like the color of that particular rectangle, 255 comma 0 comma 0 I, this will be in blue color I think, and then the thickness. Okay, so now here, CV2 dot rectangle, you know that this will draw a blue rectangle around each detected eye on the ROI color. And then XI, YI, that is the top left corner. And then XI plus width I, comma YI plus height of the eye. Okay, so the bottom right corner. And then 255, comma 0, comma 0. This is nothing but a blue color in BGR format, right? And then the thickness of the rectangle. This is what we need. Now it's good to go. We can run it and check. Do we write the program correctly or not? Let's check and see. Okay. Okay. It should be without error, but I'm not sure. Yes. So let me check with the same photo. Here I'm going to show this. It should detect the eyes and the face. Yes. It's done. You can able to see this, right? It's detecting the face as well as the eyes. Isn't it easy? I think it's very easy because we didn't create our own data set, right? We just download it from somewhere. We just upload it on our program and write our own program. We got the output. That's quite easy, isn't it? I have a question like how can we recognize third phase in real time, which will have more accuracy than front face recognition? Yes, you can. I didn't say anything like you only can recognize one face. You can recognize multiple face. If you or 3 to 4 members standing in front of the camera, in the sense it will detect all those faces also, right? If you go for some multiple picture, in the sense it will detect all the faces. You just have to alter something in the program. That's neat. But you can detect all those phases. Okay, so this is how you can detect face and eyes in real time in OpenCV. You just need to download those data sets and you can create your own program and you can alter it according to your need. Okay, so I hope you enjoy this session. In tomorrow's session, we are going to talk about face recognition. If I provide some picture, it should recognize who is he or who is she. We have to train it and we have to get the output. Okay, so it will be more interesting. So we'll talk about that in the tomorrow's session. Okay, so this is all about today's session. I hope you guys like this. So please give it a try by yourself, then only you can able to know that it is easy actually to detect speed or other physical quantities. What about speed, physical quantities, density? No, I can't able to understand your question actually. Okay, so you can convert this 21 days masterclass into 30 days internship on Jetson AI. I'm telling you this again, this is only for internship member. If you register for internship, in the sense you will get all these steps. 30 days of recording session, 30 days of presentation, 4 plus exclusive project codes. You can join to the VIP community group and you will get LMS access for 90 days. And after registration, you will get your confirmation letter. And for every week, there will be a hackathon session. First hackathon session is has already done. Okay. So I hope this week you will be having second hackathon session for second batch. And then you will be getting assignments and tasks as well, and at the end of the masterclass we will get internship and participation certificates as well, right? Okay, so the registration fees is only for 999 plus GST. So this is the registration link, you can go and grab this chance. So while making your payment, don't forget to add all these details. This is mandatory thing. And you will be doing 4 plus project with me in this particular internship. And batch 4 is going to end on coming Saturday, because Saturday is our last day of masterclass, right? So thank you all. Have a very great day. I hope you like the session. So let's catch up a tomorrow session with another topic, right? So thank you all. Have a very great day. No, Manmeet, there is nothing called the speed or track something. If you move, it will automatically detect.